Thank you for coming to my presentation on regularized graph matching for correspondence identification under uncertainty in collaborative perception. In this paper, we address the problem of correspondence identification for multi-robot collaborative perception. Correspondence identification is to identify the same objects observed by two robots in their own field of view. Or we can say it is to find the correspondence of objects in different observations. In order to achieve this goal, we need to address the challenge caused by non-covisible objects, which are those objects that can only be observed by one robot. Since non-covisible objects have no correspondence, so it will greatly affect the performance. In addition, we need to address the challenge caused by perception uncertainty, which introduce noise into the attribute and position information of objects that are used for correspondence identification. So, we propose a novel regularized graph matching formulation for correspondence identification under perception uncertainty and with non-covisible objects. Then we design an effective new optimization solver to solve this non-convex optimization problem. In our approach, we first represent each observation as a graph with node denoting object's attributes and edge denoting the distance between objects. Then we convert the correspondence identification problem as a graph matching problem. During matching, the correspondence of objects in two observations are represented as a matrix X, and the constraint on X is used to enforce the one-to-one correspondence of objects. In order to find the optimal correspondence X, we optimize X by maximizing three different kinds of similarities between two graphs, which include attribute similarity, that is calculated from a pair of objects' attributes, distance similarity, and angular similarity that are calculated from objects' positions. The optimal correspondence X is obtained when the overall similarity is maximized. However, as we know, attribute and position information of objects obtained from sensor or computer vision algorithms always exists uncertainty. The quantified attribute and position uncertainties of objects are shown in this page. We represent the attribute and position uncertainties between two observations as matrix V and U separately. Then we introduce a new regularization term over the correspondence matrix X to control the sum of attribute and position uncertainties. Intuitively, if two objects have large uncertainties, it may still be inappropriate to match them together even though they have a large similarity score. Moreover, given matrix V and U, we further generate three weight matrices, WA, WD, and WT, to indicate the importance of elements in three similarities matrices. Besides uncertainty, the non-covisible objects that have no correspondence can increase the number of incorrect matches. So we introduce the second regularization term as a penalty to the overall score. One correspondence is added to X only if the increase of the overall similarity caused by this newly added correspondence is larger than the penalty result from the regularization term. In the experiment, we first evaluate our method in connected autonomous driving scenario. Since most objects in this situation have similar appearance, visual-based method, ReID, performs badly. The traditional graph matching method, MOS, can identify most correspondence of objects, but the precision is very low because it always maximizes the overall score without considering non-covisible objects and uncertainty in observations. Our method works the best. Given the quantitative result, our method outperforms all previous methods. We observe that our complete approach outperforms two baseline methods that only consider perception uncertainty or non-covisibility, which indicates the benefit of addressing both of these challenges. We also evaluate our method on simulated and real-world multi-robot coordination scenarios. In these scenarios, our method still achieves the best performance. Thank you for watching my presentation, and see you in the virtual interactive section.